Hello everyone, welcome to the part 5 of handling netCDF files tutorial series. Now in this tutorial, I'm going to show you how to create a time-lapse from your netCDF plots, which you learned how to do in the part 4 of this tutorial series, and to create a time-lapse or an animation that looks like this. Pretty cool, isn't it? So let's go ahead and learn how to do this. Alright, so at the end of the part 4 of this tutorial series, I showed you how to generate this kind of a matplotlib graph. How to basically transfer the details of your netCDF files into a graph like this. So I'm actually going to use the same script over here in order to do this task of creating a time lapse. So let me go ahead and get rid of this plot. And even though I'm going to use the same script for the most part of it, I'm actually going to make a few slight changes. So let's navigate back to the folder that you would like to work in. Select the folder and go to File Explorer, and let's create a new script. Temperature data time lapse. Alright, so let me just go ahead and select this whole thing and copy it to over here. And I'm going to go ahead and close this one now. So now if I run this script again, you see that we get the same output, so everything seems to be working fine. Alright, so I'm just going to go ahead and close this one. So at the end of the previous tutorial, part 4 of this tutorial series, I actually told you that the 0 refers to the first day of the year 1962. That's the 1st of January. So let's say, for example, we select one of those dates, maybe from the mid of the year, let's say around 150. So accordingly, the title should be changed to average temperature on the 150th day of year 1962. Alright, so now I can just go ahead and run the script. Alright, now you see that we get the corresponding data. We get the data which corresponds to the 150th day. So you basically get the idea how to access the different dates by changing the value over here. So for example, we have 365 days, but since the index value of the time starts from 0, we have the values only up to 364. For example, if I put over here 365, and if I try to run this one, I will definitely get an error. Yes. So just like that. So what I'm going to do is actually I'm going to create not only one graph per one time. I'm actually going to loop through all these 365 days, and I'm going to create different graphs at each different day, and I'm going to save those graphs into let's say into a JPEG, and I'm going to collect all those graphs into a separate folder. So let's see how we can do that. So I guess you agree that all the way up to here it should be the same, the code should be the same, because here what we do is only specify our boundary, and it's just over here where we specify in the program the data corresponding to which day, which exact day are we actually going to plot in our figure. So what I'm going to do is I'm actually going to go ahead and create a variable called days. And now for the year 1962, I know that we have 365 days. And I'm going to create a NumPy array using np.arrange, which starts from 0 and ends at 365. Alright, so if I show you now what happens if I execute this small piece of code, you see that we have an array which starts from 0 and ends at 365. So I'm actually going to iterate through each and every entry like this, which basically corresponds to the 0th day, the 1st day, the 2nd day, the 3rd day of year 1962. So what I'm going to do over here is actually for each particular day which corresponds to index number 0, 1, 2, 3 all the way up to 364, which actually corresponds to the 1st, 2nd, 3rd, 4th all the way up to 365th day. I'm going to loop through each and every day and I'm going to generate the corresponding temperature map, and I'm going to save it into a JPEG. Alright, so now since this is done, I'm actually going to go ahead and create a for loop. So I can say something like for I in days. Now keep in mind that this I is actually a variable that you're assigning. If you would like to assign different name for that, you're very welcome to do so. But just for the purposes of this tutorial, I'm going to use this one as I. And now I'm actually going to push this whole thing by one tab. And instead of specifying a solid figure over here, I'm actually going to specify I. So what happens is when this is looping through 0 up to 364, the value of I is also going to change from 0 all the way until 364. That means the value over here is also going to get changed from 0 up to 364 during each iteration. So that's precisely what I want, isn't it? Alright, so these three lines, I can leave it like that because I would like to draw the coastlines, the states, and also the countries. And the color bar, I think I can still retain it. No need to make any changes. Now just in the title, because as you can see that now for each iteration the title should actually change. So just to keep the things a bit simple, all I'm going to do is just going to say it's the average temperature day, and now I want to actually use this I value because during each iteration the value of I is going to change. But actually let's say when the value of I is 0, my actual date is actually day number 1. So what I'm going to do is I want to put this as I plus 1. These values are integers. Now I'm trying to add an integer into a string, which is not really possible. So what I'm going to do is, alright, so my objective over here is actually during each iteration I would like to specify which day it is going to be exactly. So for example, when the value of I is 0, I would like to say that this is the average temperature for day number 1. And when the value of I is 1, I would like to say that this is the average temperature for day number 2. I guess you get the idea behind that, because what we specify over here as I is basically the index, which is 1 unit less than the actual date itself. So what I can do over here is I'm actually going to create another variable called day. And that's basically going to be equal to I plus 1. Just for the simple reason which I just explained. So now I'm going to specify the title as average temperature day, and now I'm going to add this day variable over here. Now over here we've got a small problem because this I is actually an integer. So during each iteration, no matter what the value of this I is, it's going to get its value increased by 1. But still it's going to end up as an integer. So, but the issue is we cannot add integers with strings. So before adding this, I actually have to convert this into a string, and you can do that on the spot. You don't need to create a separate variable. Actually, if you want, you can, but there's no real necessity of doing that. So for example, during the first iteration, it's going to display something like average temperature day 1 of year 1962. Alright, so during the second iteration, it's going to say that average temperature day 2 of year 1962. Alright, so if you can recall the figure back over here, you see that we do have a scale. Now when we go through different iterations, actually this scale can change. But if the scale keeps on changing from one figure to another, actually we won't really have a very accurate representation of how the temperature changes over the different days or over the different weeks, because it will automatically adjust to sort of represent the data in the best way. So because of that, if we need to create a time lapse, it's very important that we set the upper bound and the lower bound of the temperature range to be a constant. So you can set that simply by saying plt.clim. So in this case, I'm actually going to set the range to be from -40 up to, let's say, +40. All right. And now I'm going to enter the statement which actually saves this figure, which is plt.savefig. Now over here, what you can do is you can specify this file name over here. If you want to save it into a separate folder, you can do that. You can do that as well, but in this case, since my working folder is actually over here, I would like to save all the files into this this folder itself. What I can simply do is I can actually specify the day over here, and I'm going to convert that into a string, str plus. It's really important that you specify the file format, which is JPEG in this case. And finally, during each iteration, you actually want to clear your figure, which means whenever you record a figure onto this plot, you actually want to sort of get rid of the previous plot. So in order to do that, you can just go ahead and type plt.clf, and that should do it. So just to give you an example, let's go ahead and shorten this to maybe only about 10 days. So, and let's run the command and see what happens. If I open the file explorer, now over here you will see that we actually get different JPEGs, and finally 10. Right, so if I just go ahead and open the corresponding folder, now you see that we actually have the average temperature starting from day number 1 of the year 1962, and we can go to day number 2, day number 3, day number 4, 5, 6, 7, 8, 9, 10, and so on. And you can see how the temperature actually varies from each day to the other. So let's go ahead and not do this only for 10 days. Let's do it for the whole 365 days. So I'm just going to enter 365 over here. And let me go ahead and get rid of all these files. Well, I feel like it's better to collect all the generated JPEGs into a separate folder. So maybe I will create another folder over here. Maybe I will name it as JPEGs, simple. And then what I can do is I can specify the path over here to which the files should be saved. So that I can specify by R. Alright, like this. So just going to go ahead and run this script now. And then you will see how each and every file actually gets collected into this particular folder. Alright, now since the process is actually going to take some time, I'm just going to, it might take a few minutes, I guess. Alright, so once it's done, you can see that we have gotten the image file starting from day number 1 all the way up to day number 365, isn't it? Alright, so now let's go ahead and see how we can do the animation in order to change the figure from one to another, all the way from the day number 1 up to day number 365 fully automatically. So we are going to do this actually by creating a GIF out of all these images, starting from the first image up until the 365th image. So I'm just going to go ahead and close this one. Now, if you want to create GIFs, one way that you can do is actually simply by using one of the Python imaging libraries, which is called Pillow. So for this tutorial, you will have to actually, in order to generate the GIF to automate the figures, you will have to actually install the Pillow using pip. So I'm just going to simply go ahead and open my Anaconda prompt and run it as the administrator. And what I can do is I can actually go ahead and type pip install pillow, just like it is mentioned over here with a capital P. Alright, and press enter. And since I have already installed this package, you see that it says the requirement is already satisfied. But in your case, if you haven't installed this library before, you will see that it will get actually installed without any issue. So after that, you can just go ahead and close, get rid of all of these. And the code, in order to generate the GIFs, I'm actually going to write it in a separate .py file. So I'm just going to go ahead and open the file explorer. And let me create a new Python module. And I'm going to name this as temperature data time-lapse generate GIF, generate a GIF file. Alright, so what you can do is you can just go ahead and import the pillow library which you just installed, but keep in mind that when you import the library of pillow, you actually don't import it like this. Instead, what you do is you just type PIL all in capital. Alright, now you can run the command and see whether you have any errors or not. Now you can see it's all clear, so you can proceed. Now I'm going to create another variable called image frames, which is going to be an empty list to start with. And let me import the NumPy library as well. Import NumPy as np, just because I would like to create another variable called maybe days that's going to be equal to np.arange starting from 1 up to 366. Alright, now let's go ahead and run this one. Now if you're just wondering why I specified it to be 1 from 366, because this is how it looks when you expand it. It starts from 1, ends at 365, and if I go back over here to my files, my first file starts from 1 and the final file ends in 365. What I'm basically going to do is I'm actually going to loop through each and every file starting from 1 to 365. That's basically the trick behind it. Alright, so let's go ahead and loop through each and every file. So I can do that by creating a simple for loop. I'm going to pick a variable maybe called k days. So in each iteration the value of k will be 1, 2, 3 all the way up to 366. Sorry, all the way up to 365. Now let me go ahead and create a new variable called new frame, which is going to be equal to, now we are going to use this pillow library, pil dot image dot open. Alright, so in each iteration I would like to open each of these jpeg files. So let's say during the first iteration it should be this path r. Let me go ahead and squeeze this one a bit, plus 2 more backslashes, plus. Alright, if it's the first picture it'll be something like 1.jpg, isn't it? If it's a second picture it'll be 2.jpg. If it's a third picture it will be 3.jpg. Alright, so now you get the idea. What I'm going to do is I'm also going to leave a bit of space over here, and I'm going to add this k variable over here, and I'm going to add that. I think now it's clear. However, there's a bit of a problem. During each loop this k is actually going to get recorded as an integer. So now since I'm going to sort of incorporate that integer into this path, I have to convert this into a string. Only then it will get added into the rest of the path. Alright, now what I'm going to do is I'm going to take this empty image frames list and I'm going to append. What I'm going to append is basically this new frame. So what it's going to do is, okay, during the first iteration, this image frames is actually an empty list. So at the end, I'm going to add this new frame, which corresponds to the first JPEG, into this. And in the second loop, it's actually going to append, means we already have the first one, and it's actually going to create the second entry using the second image, and so on. So let's run this one, and let's go ahead and open the variables explorer. Now if I open this image frames now, over here you can see that actually it's still a list, but now it has different image files, as you can see over here, because it's now storing all the images. So for example, if I say that image frames, and if I check the type, you will see that the type is actually still a list. So the way you access different elements of a list is you just type the name of the variable image frames, and over here if you specify number 0, that means you're actually calling the first entry, which should give you this image. Similarly, if you try to select the second entry, you have to enter number 1, and that should give you the day number 2. And if you want to select the third entry, you have to press enter day number 2, because we are talking about indexes over here. It's going to give you day number 3. And similarly, if you want to access day number 365, you need to give the index, which is 364. That's corresponding to the day number 365. Now you see that it's just like a simple list, but this list is now full of images, 365 images. Quite a heavy list, isn't it? Alright, now let's go ahead and try to put all these images into one GIF. So you can simply do that by specifying image frames. Let's say I'm starting from the first image and I'm going to save. Now I need to give a file name for the GIF file. Let's say temperature time-lapse. Alright, .gif, quite important. And then over here you need to specify the format. What's the format? Is equal to, or maybe I can specify it over here, the format that's equal to GIF. Alright, with a comma. Now I can append images. Now this append images is also actually an argument. So the images that you're going to append is basically these image frames. Since we have the first entry over here, which corresponds to the 0th index, we can actually specify everything else by specifying 1 and leaving a colon over here. Basically that selects the entire set of the other pictures apart from the first one. Alright, now since you want to save all those images, we specify the save all argument to be true. And we can also specify a duration. Maybe I can put it as 300. Now the units of this duration is actually in milliseconds. And finally, I can also specify a loop, and I'm going to put the value as 0. What this does is actually it's going to create an infinite loop. So after it creates this temperature time-lapse GIF, it's actually going to keep on looping all the way from the first image up to the 365th image, and again starts from first to the 365th and so on until you stop the image, until you close the image. It's quite normal if you are just currently wondering how on earth I'm actually getting these different arguments. So I'm not actually doing anything by heart. What you can do is you can also actually go to the official documentation of this Pillow library, and over here you can see that there are many other parameters that you specify. For example, this duration, which we specified to be 300. it's in milliseconds. And yeah, loop may not be present. The number of times the GIF should loop. 0 means that it will actually loop forever. So these kind of things, actually you can even go through this documentation, which I'll put the link down in the description below. So that's basically it. Now we can just run the command, and you can see that it's still running because it's going to be quite a heavy file. You're sort of combining 365 JPEG images into one GIF, so that's definitely going to be a heavy file. Right now it seems like it's done. So since I did not specify a path over here, where this is going to go is to the place which is actually my current working directory, which is this one. So just going to go back one step, and this is the temperature time-lapse GIF which I created. Now you can see it's actually of 24.6 megabytes, so quite a heavy file. Now if I open this one, you can see that it's actually opening in your browser, and it's basically producing an animation for you starting from day number 1 all the way up to day number 365. Now if you would like to, if you would like to speed it up a bit, maybe you can specify the duration to be a bit faster, maybe about, let's say, 200 milliseconds. Then you can run this, and you may wait while it gets executed. Alright, seems like it's done. Alright, now you can see that starting from day number 1 all the way up to day number 365, how the temperature actually ranges. Now you can see that as we approach the mid of the year, about June, July, you can see that actually the temperature is sort of getting quite red over here, which means it's going to move to the upper bounds of this scale, which is almost in its 30s to 40s over here. And by the time we reach to the end of the year, probably by October, November, December, the temps will actually cool down a little bit. So that's what you see over here now. Slowly, as we are approaching the end of the year, you can see that somewhere over here in China, it's already blue over here. Now it's actually going again from day number 1, just like an infinite loop. So I guess you got the basic idea of this tutorial, how to create a GIF, how to create an animation, or basically a time lapse of temperature data which you created from the netCDF information which you downloaded for a specific variable, in this case temperature. So I guess you enjoyed this tutorial. If you did learn something new, you can always hit the like button and show your support. And if you did really like the video, you can even consider subscribing. So thanks a lot for watching, guys. I'll see you in the next one.